on to part D here, and the first thing I see is a cosine that I would really like to have an r next to it. And I'd really like to have an r next to it because remember, x is equal to r cosine theta. So why don't we just start off by multiplying both sides of this equation by r. So it'll give us r squared equals 6r cosine theta. Right? You can always multiply both sides of an equation by a number without changing the solutions to the equation, as long as that number is non-zero. Okay. So there we go. Next, also note that this means we can rewrite the right-hand side as 6x, because r cosine theta is equal to x. But you also might remember that r squared is equal to x squared plus y squared. So we'll go ahead and we'll do that. X squared plus y squared. Okay. Next step here is we could move that 6x over. So we'll have x squared minus 6x plus y squared is equal to 0. Okay. Now, you can try and solve this for y, and that actually would work out fine, but you might have trouble telling what it is if you try to solve this for y. The key here is we can actually rewrite this in the form x minus a squared plus y minus b squared is equal to r squared. We can write this as a circle. We just need to figure out what we need to add to each side here so that we can complete the square. And as what I mean precisely here is we're going to try and rewrite this x squared minus 6x. We're going to add a number to it so that we can write it as x plus or minus something squared plus y squared, and we'll also have some number squared over here. And if we do that, we'll have the equation of a circle. So the trick is there's this little formula, and it looks like this. C is equal to b over 2 squared. So this is that number that I'm going to add to each side. So I have this x squared minus 6x, and then we just need to compute what this number is. B for us is actually this minus 6, this number in front of the x. We have minus 6 over 2 squared, which is negative 3 squared, which is 9. Okay. But I actually want to do one more thing. I'm going to actually write minus 3 squared, which is 9. Okay, and I'm going to try and write that a little neater. Okay. So that's the number we're going to add to each side. Plus 9 is equal, or plus y squared now, is equal to, and then we have a 0 plus 9. So we have 0 and then plus 9. And it ends up that we can factor this part that we've just underlined here. This can be rewritten as x minus 3 times x minus 3, or x minus 3 squared. And then this 9 over here on the right, I could just rewrite that as 3 squared. Okay. Now, there was a little bit of trick to this factoring down here. So it actually ends up, if you simplify that b over 2 in the inside here, whatever that number winds up being, that's what's going to go right here. You can see we had minus 3, and we have a minus 3 there in our factoring. But you could have also used the old trick, what two numbers, add to the middle term and multiply to the last term, which was 9, and those two numbers would be minus 3 and minus 3, which would mean that it would factor, that x squared minus 6x plus 9 would factor into x minus 3 times x minus 3, which is equal to x minus 3 squared, which is what we wrote. So after all this work here, So what we found is we have a circle. Let's see precisely what circle though. So circle centered at 3, 0, right? It's supposed to be x minus a, so our a was 3, and then plus y minus b, and so our b was 0. We have y minus 0 squared. So circle centered at 3, 0 with radius 3. So the radius is whatever number is being squared here on the right. Example 7. So we are now going to try and go from Cartesian coordinates to polar coordinates. So the equations that are going to be really helpful for us here are going to be just x equals r cosine theta and y equals r sine theta. And this is going to be immediate. So x here I'm going to replace with r cosine theta. And y I'm going to replace with r sine theta. And when we're in polar coordinates, we prefer to have the equation y equals, or not y equals, r equals. Just like in Cartesian coordinates, we prefer it to be y equals, right? So in order to make this one here r equals, is what we're going to do is we're going to factor an r out of that left-hand side. And so that's going to look like r times cosine of theta plus 5 sine of theta is equal to 8. And you can see here that, well, let me put the parentheses in the correct spots here. There we go. You can see here if we were to distribute our r back through, we'd end up with what we started with. Okay. So this looks good then. Next step, let's finish this and actually solve for r. So if we divide each side of this equation by cosine theta plus 5 sine theta, this is going to leave us with r equals 8 all over cosine theta plus 5 sine theta. So that simple linear equation is this mess in polar coordinates. So you can see here, if we were going to do something that involved linear lines, it would probably be much easier to stay in Cartesian coordinates and leave the polar stuff for things that are really curvy, like circles, or things that maybe look like flower petals, stuff like that, or a propeller looking. Okay. Let's try another one. And we can actually do the same thing here. We can just replace the x's and the y's with r cosine theta and r sine theta. Let's go ahead and do that. So it's going to be r cosine of theta. Actually, I'm going to write it without the parentheses there. And then plus r sine theta plus 2 squared is equal to 4. And let's just go ahead and square each side here. If you square r cosine theta, that gives you r squared cosine squared of theta. And remember here, we're going to have to FOIL. So if we do this times itself, that's r squared sine squared of theta. Then if we do the first term times the second term, that's, let me fix my theta here. Again, the first term times the second term, that's going to be plus 2r sine theta. And then we'll end up having another one of those plus 2r sine theta. Remember, we're foiling. And then finally, if we multiply the last term by itself, that's plus 2 squared, which is 4. And so you might already see, if we subtract by 4 on each side, we are going to lose these 4's. And you might see something else, particularly with these first two terms. See that they both have one has a cosine squared, the other one has a sine squared, and they both share an r squared. Why don't we try and factor out an r squared? And then you can tell me if you think that that looks helpful or not now. Right? What's in the parentheses here is equal to 1. So this just becomes r squared plus 4r sine of theta is equal to 0. All right, and we can actually solve this thing for r if we want, or we could leave it like this. I think we can take this a little bit further in an easy way. There's actually two ways to do it. We could actually complete the square here to solve for r, or we could factor an r out. And so if we do that, we have r times r plus 4 sine of theta is equal to 0, which tells us that either r is equal to 0 or r plus 4 sine of theta is equal to 0. Well, let's think about if these both make sense or not. R equals 0 is just a single point. That's the origin. Okay. Doesn't matter what angle you pick to go with r equals 0, we're at the origin. So this isn't it, okay? Unless the only points that satisfy this are 0, 0. But they're not. There's other points that satisfy this. Okay? So this r equals 0 over here, we can say, well, we know it's not that. So, and if we take the second one and we actually solve it for r, we have our equation r equals minus 4 cosine of theta. And that should be a sine of theta. So r equals minus 4 sine theta. There we go. And if you wanted to verify this, you could graph these both on your calculator, one in polar and one in Cartesian coordinates, and they should give you the same graph. Okay. And they should both be a circle, right? This one here is a, see if we remember what this is. This is a circle centered at 0, minus 2 with radius 2. Okay. So that's what we should see when we graph both of these on our calculator. All right, and that's it.